section is kind of a little bit of everything put together about shapes. So we're going to be dealing with a little bit of perimeter and area. We're going to talk about a little bit of similarity. We're going to be dealing with finding perimeter and area of multiple shapes put together, which we'll call composite figures, and that's what Ms. King will teach you on Thursday. And really on Thursday it's not going to be too bad because it's just what we've done today and tomorrow put together. Okay. Next week in 10.5 and 10.6, we'll talk about probability with geometry that deals with perimeter and area. So this chapter is a lot of perimeter and area dealing with two-dimensional shapes. Okay. So we're going to start with you guys reminding me some of the formulas we learned way back in chapter 1, section 5, that you should have come to geometry already knowing, but we definitely reviewed them. And that is, if I have a triangle, what is the area formula?
Base times height over 2.
Okay, so base times height divided by 2, or you could write it as 1/2 base times height. Either way is fine. Okay, if I have a square, what is my formula? Okay, I could do base times height, but that's not going to be helpful some of the time when they only give us one dimension. So what is the actual formula for a square? Side squared. Okay, just side squared, because the base and the height are the same. So base times height when it's the same is just base squared or height squared or side squared. All right, if I have a rectangle, what is my formula? Okay, so it is area equals base times height. Let's talk perimeter for both the square and the rectangle. And by the way, I should warn you, for chapter 10, there will be no vocab test, but you will have a formula test. And it will be on the day we review, just like the vocab test. So these formulas I'm writing on the board are formulas you're going to need to know, and so you may want to write these down somewhere. Next week sometime. All right, what about perimeter? How do I find the perimeter of a square? 4s. Because there's 4 sides, so 4s plus s plus s plus s is just 4s. Rectangle, how do I find the perimeter? Okay, 2 base plus 2 height. They may say 2 length plus 2 width, or they may say 2 base plus 2 height. It depends on if they're calling the area base times height, or if they're calling the area length times width. Same thing, right? Just whether they call it a base or a length, width or a height. Okay, so those are things we learned back in chapter 1 you're going to have to use for this section. New formulas for today, and these will be on your formula test as well. So the ones from chapter 1 as well as new today. Does anybody know the area formula for a parallelogram? It would still be base times height. The difference is, in a rectangle, the height is one of your sides. In a parallelogram, that is not the case. So if I have a parallelogram, okay. So if you, auxiliary line would be kind of sort of, we're not really writing a proof, so it's not really the same as an auxiliary line, but yes, we're going to add a line. Your height would have to go perpendicular between your bases. So it could be from here to here. It could be outside your triangle from here up is your height, or it could be outside your triangle here from here down is your height. Anywhere the perpendicular distance between those bases would be your height. So it's still base times height, but it's not one of your sides. So that's where you have to be careful. Good. All right. What about a trapezoid? Does anybody know the area formula for a trapezoid? Good, Alexis. So area equals 1/2. Tell me again. Base 1 plus base 2 times the height. So the difference in a trapezoid is you have 2 bases. So we call the top base 1, the bottom base 2, and the height then again is that perpendicular distance between them. So that height could be inside the triangle, or it could be drawn outside the triangle, or excuse me, the trapezoid. So inside height or outside height, it just has to be drawn so that it is between the bases perpendicular. Very good, Alexis. All right, how about rhombus? Don't look at the notes. Does anybody know the formula for a rhombus? It is not s squared, because a rhombus does not have 4 right angles, so you can't just do s times s. Okay, so a rhombus is a type of what? parallelogram. So it's going to have two formulas. One formula is base times height, but then it also has a separate formula. Okay, we'll come back to it. But it is a parallelogram, so it could be base times height because it is also a parallelogram. Depends on if they give you the base and the height. All right, last shape for today is the kite. Does anybody know the area formula for a kite? Okay, so the good thing is that there's not a whole lot new today, right? We just have to add in a few formulas, but would you agree that you probably, for sure, I know you saw the first three, and maybe you've seen the parallelogram or the trapezoid before mentioned, maybe. Okay, so, and the rhombus, one of the formulas is the same as the parallelogram. Okay, so I'm just going to skip ahead in the notes, and we're not going to like develop these formulas. I'm just going to believe me that they're true. You can read through them in your notes, look in your book if you want to develop the formulas on your own. What's super important is this area addition postulate for Thursday when I'm not here. The area addition postulate simply says that you can find the area of a region, which on Thursday is going to be called composite figures. So for example, you'll have something like this. What does that look like? Ice cream cone. And what two shapes could we divide it into? Triangle. And what do we call half a circle? Semicircle. So we could do half of a circle and a triangle. We could find the area of those two things and add them together, right? So on Thursday, that's what you'll be doing a lot of, is just simply applying the formulas you learned today and tomorrow to, or today and Wednesday, to what you're doing on Thursday. You could. It's going to depend on what information you know. So you could divide your trapezoid into a rectangle and triangles. And again, it depends on if it's isosceles or not isosceles, but it depends on the information in the picture, and it may or may not be enough to give you the answer that way. Okay? Yes, ma'am. So it will be, but we're going to talk about circles more tomorrow on Wednesday. I keep wanting to say tomorrow, but tomorrow we're testing. On Wednesday. So yes, we'll review circles on Wednesday. Close, but yeah, but we'll review it on Wednesday, okay? So area addition postulate just simply says you can divide a shape into, let me go back real quick, into those parts, and then you can just add them together, okay? Just make sure that it's not the overlapping part. You don't count it twice. So notice the ice cream scoop may go down below that triangle, but you're not going to count that ice cream scoop as a full circle because it's already covered with the triangle. So you'll have to think about some of the problems a little bit and be really careful. All right, so this is where they go through and develop the formula for a parallelogram. Again, you can read through all of that to understand why it is what it is, but I'm going to just tell you that your area formula for a parallelogram is base times height. And again, I want to point out that the height has to be the perpendicular distance between your two bases. So two parallel sides can be called your bases. Your height's the perpendicular distance between them. One thing that you should be careful about, what that's going to do in a lot of these pictures is if you shift that height over here to this vertex and draw it straight down, what have you created right here? What kind of triangle? Right triangle. So in some of these problems, you may have to do Pythagorean theorem. You may have a special right triangle, 30, 60, or 45, where you have to use those relationships to find your height. So it's going to be, we're going to connect a lot of the things we've learned in this chapter as well. Okay? It could be that you have to use sine, cosine, or tangent to figure out your height if they don't give you a special triangle or Pythagorean theorem information. Yes. So all of that could apply and will apply. We will use trig for sure on Wednesday. Wednesday is probably the hardest lesson of the whole chapter if you understand 10.5. 10.5 sometimes tends to be the harder section, but the content in the lesson on Wednesday is often the hardest. Okay. So what I left for Mrs. King to teach, it worked out beautifully, is probably the easiest part once we've learned today and Wednesday. So it should go well for you. Okay, here's where they remind you about squares, but I've already listed all of that on the board. So again, if you haven't written that down, you're going to want to do that. I already said that. We've already talked about that. So then there's some problems. I'm going to skip the problems for right now. We're going to come back and do the examples, but I want to get through the formulas. So let's skip ahead to the formulas. We'll come back and do all the examples at once. And some of these examples are just going to get harder because of all the algebra that's required in them. So you'll notice all these x squareds and algebra expressions. All right, so then the next formulas, if you'll find this chart, everybody with me here. We have the triangle, which you guys already told me was 1/2 base times height, and then we have the trapezoid, which Alexis told us was 1/2 base 1 plus base 2 times the height. Or for those of you who prefer to write base times height divided by 2 on a triangle, you could do base 1 plus base 2 times the height divided by 2. So if you prefer to write it this way, that's fine. Okay? Again, I want to point out that height has to be the perpendicular distance between the bases, and you could slide it left or right so that you create a right triangle. And then you may have to use those things to find your height. Okay? Any questions so far? All right, again, I'm going to skip some examples and move on to the last formulas that we have in the notes. Rhombus and kite. And so you guys gave me the rhombus is a parallelogram. So we know that it is also base times height, right? But this right here is what's going to lead us to our last formulas. Remember that in a rhombus and in a kite, both of them, that the diagonals are perpendicular. Okay? Part of what's going to make this chapter hard too is that you're going to need to remember your properties of your quadrilaterals from back in chapter 6. And you have a very detailed property sheet if you didn't get rid of it, which I hope you didn't. If you remember, we made a long list of all our properties in chapter 6. So if you're doing your homework and you can't remember, pull that property sheet out, review it, and then hopefully by test day of chapter 10, it won't be a big deal. Okay? But the diagonals of a rhombus and a kite are perpendicular. And because of that, they will have the same formula for area. The rhombus is going to have two formulas because the rhombus is also a parallelogram. So it's going to be base times height, as well as formula number 2. Its area is going to be 1/2 diagonal 1 times diagonal 2. 1/2 D1 times D2. Diagonal 1 times diagonal 2. The kite will have the same formula, 1/2 diagonal 1 times diagonal 2. Most commonly missed formula from this lesson will be the kite and the trapezoid, because some students will end up multiplying their bases instead of adding them, and they'll add their diagonals instead of multiplying them. Be really careful. Trapezoid, you add the bases. Rhombus and kite, you multiply the diagonals. Any questions? So you can work from left to right. Remember that the rules for multiplication order does not matter. So if I did 2 times 3 times 4, it wouldn't matter if I did the 3 times 4 and then the 2, or 2 times 3 and then times 4. So you can either take half of diagonal 1. There's no plus or minus signs. So you're not distributing. You're just multiplying from left to right. So half of diagonal 1 and then multiply by diagonal 2. Or you could do diagonal 1 times diagonal 2 and then multiply by 1/2. Does not matter. You'll get the same answer. Does that make sense? The diagonal, by definition, goes from one vertex to the not consecutive vertex. So this is the entire diagonal. This is the entire diagonal. Is that what you're asking? Okay. So yes, it's the whole diagonal. Notice that they put a D1 and drew an arrow. Sometimes they will do that. That means they're telling you the length of the entire piece. Sometimes they'll put a number beside the diagonal, like 12. That would mean they're only telling you that part of the diagonal, not the whole diagonal. So if they're giving you the whole diagonal, they'll put D1 and draw an arrow. Otherwise, they'll have to list it in separate pieces and tell you parts 12, part 6, the whole thing then is 18. Does that make sense? All right, so that's the big idea of the lesson today, is you just have to know all of these formulas. There will be more than that before we take the formula test, and I will tell you exactly how many and what all is going to be on that formula test, okay? But then the rest of the notes is just applying the formulas to some harder problems. So we're going to go back to the very beginning, and if you leave at 10:30 and miss anything, just know you're missing examples, and you can go back and look at those. Sorry, it's going to take me a minute. Is this the first one? Right here? Okay. So first thing you're going to do is ask yourself, what shape do I have? This is a parallelogram. The next thing I'm going to tell you is on the test, if you do not write the formula, you will get 0 partial credit. I'm going to say that again. When we take the Chapter 10 test, and this will go for Chapter 11 as well, because we will learn a lot of formulas in Chapter 11, if you don't write the formula and you miss it, even if it is you rounded incorrectly, I will give you 0 partial credit. So you better make sure that you either write the formula or that you're confident you're perfect, because the only way to earn partial credit for this chapter is to start with the formula. Okay? So if it's a parallelogram, we're going to start with area equals what formula? Base times height. Look at your picture. Make sure that you can find the height between the two sides you're going to call the bases. So when I look at this picture, I could let this side and this side be the bases. But do I know the perpendicular height between them? No. And do I have enough information to find that perpendicular height? Not in those blue sides. If we switch and we use these two sides and we let 11 be the base, do we have enough information to find the perpendicular height between those two bases? Okay, how? Okay, 34 on this side is also 34 on this side because in a parallelogram, opposite sides are congruent. And now we have a right triangle. What will we have to do to find the height? Pythagorean theorem. So this is where these problems just get a step harder because you've got several things to do. So first we're going to find our height by doing h squared plus 30 squared equals 34 squared. If you don't have a calculator, you're going to need it. So jump up and grab one. All right, so we have h squared plus 900 equals, I don't know what 34 squared is. 1,156. Okay. And then I will subtract 900 to get 256 equals h squared. Take the square root of 256, which is 16, so my height is 16 millimeters. Questions on finding our height? Okay, then we'll just go back and plug that into our formula. So what's the length of the base again? 11. So be real careful in your pictures. And we'll do 11 millimeters times 16 millimeters. 176 what? Millimeters squared. So remember when you're finding area, your unit should be squared because you're doing millimeters times millimeters, which is millimeters squared. And if you're finding perimeter, you would not square your units. Okay? Any questions on that one? Don't let me go too fast. I see some of you are still writing, so I'm going to slow down. Oh, by the way, there are two things I forgot we're supposed to do this period, so let's stop for just a second and do those things. Number one, you're supposed to look at your Encore Viewer 2.0 because there was no Encore today, and you need to go ahead and assign yourself Encore for Wednesday. So go ahead and do that real quick. If you need your Chromebooks or phones, we'll just pause right here. And dealing with more of our expressions having variables in them, just keep in mind if your equation started with variables, it's highly likely that you are going to end up with a variable in your answer then, okay? So it says find the height this time of a rectangle given the base is 3 and the area is this. So again, on the test, what's the very first thing you should be starting with? Formula. So what formula will we start with? Area equals, okay, and I also want to warn you, a formula is an equation. So if you just write BH, you have not written down the correct formula. The formula is A equals BH, okay? Because you need the A to plug all of the area in for. So we're going to plug all of this 6x squared plus 24x minus 6 in for A. They're giving us the area. And then what are we plugging in for B? 3. And we're looking for H, right? So we just divide by 3, and just keep in mind that every single term gets divided by 3. So the 6 is divided, the 24 is divided, and the other 6 is divided. Okay, so if we simplify that, what do we get for H? 2x squared plus 8x minus 2 equals H. I didn't keep my units in my work. I could have, so that you could have seen what happens with those units. This was inches squared, and then we divided it by inches, right? So what should the height be measured in? Just inches, right? Are we good? Yes. That's the answer. It just said find the height. Because your area started with variables in it, your answer is going to have variables in it. Okay? It did not say solve for x. You're not trying to figure out what x is. Well, we don't have enough information to solve for it. They'd have to tell us what the height was equal to in order to solve for x. Then if they told us what the height was equal to, we could set it equal to 0 and factor and solve for x. But at this point, we don't have enough information to figure out what is x. Okay? So just keep in mind, if your problem starts with variables and all it's asking for is h or b or l or w, then you're probably going to have a variable in your answer. Okay, so another one, find the perimeter of the rectangle given the area, and they give you some information in the picture. So what formula will we start with here? Oh, careful. This is saying find the perimeter. Okay, so what formula are we going to start with for perimeter? 2L plus 2W. So that means what do we need to know based on the picture? What do they give us in the picture? Okay, so we used L and W here, so what do you want to call that instead of base? Length, doesn't matter. But so this is the length. So let's go ahead and plug it in. So 2 times 21 plus 2 times W. What's 2 times 21? 42 plus 2 times W, and then we're stuck, right? Because we need to figure out what the W is. So we go back to the problem, and what do they give us? The area. So we need to use that formula. What's our area formula? Base times height. They give us, and I'm going to stick with length times width here instead of base times height just to be consistent since we used length and width in the perimeter. Okay? So area equals length times width. They give us the length is how much? 21, and we are trying to solve for the width. But they give us the area, right? So we need to substitute in this expression for the area. So we're going to have 79.8x squared minus 42 equals 21 times W. So when you get to these harder problems, start with what you're trying to find until you get stuck. Then take the other information and use the next formula and work until you can find what you needed to answer your question. So what are we going to do here to solve for W? Divide by 21, because we plugged our 21 in for L, so now we're just going to divide everything by 21. Again, make sure you divide every term by 21. Okay, so that gives us W equals, what's 79.8 divided by 21? 3.8? Okay, so 3.8x squared minus 2. Again, we're not trying to solve for x, we're trying to solve for W. So that's as far as we can go, and all of that's going to get plugged in for W over here into our perimeter problem. Is this making sense? Okay, so then we have the perimeter is equal to 42 plus 2 times, and we're plugging in that 3.8x squared minus 2. What do we need to do? Distribute, multiply. So we're going to distribute the 2 to both. That gives us 42 plus 7.6x squared Minus 4. You got it. Minus 4. And then we need to do what there to finish? So combine like terms, 42 minus 4. So what is 42 minus 4? 38. So we have 7.6x squared plus 38. And so when you write your answer, it should always be in descending order of your exponents. X squared first and then your constant at the end. And what are our units going to be? Just centimeters, right? The only time you're going to square it is if you're finding area. Perimeter, length, width, height, base, all of those will just be centimeters. Area is when your units are squared. And again, if you have a variable to start with, more than likely you're going to have a variable in your answer because you're not trying to solve for the x, you're trying to solve for something else. Questions? Okay. I probably hit it way too many times now. Okay, so this one is super simple. I'm going to skip it because it is just, they gave you everything and you're just plugging it into the area of a trapezoid formula. There's really, there's no difficultiness to this. They give you the base 1, they give you the base 2, they give you the height. You just substitute it in. Is everybody following that up there? And then you would just solve. So I'm going to skip this one because it's really easy. And let's go to a harder one, okay? I feel like the harder ones are when we have to plug our algebra in along with our formula. So what are we trying to find here and what are we given? Base. All right. And what do they give us about the triangle? Okay, they give us the height and they give us the area. So what formula do we need to start with? Okay, area equals, and you can either write it as 1/2 base times height, or if you prefer, you can do base times height divided by 2 equals area. But make sure you're putting A equals, okay? So, which way do you want to do it? The first way with 1/2 or BH over 2? Okay, so I'm going to do BH over 2, and then if that causes us trouble, we can go back and do 1/2 base times height. What's going in for A? 15x squared equals, what's going in for B? We don't know, so just B. And what's going in for H? 5x, and it's all divided by 2. Okay, and again, our goal is not to solve for x here, it's to solve for the base. So what's the first step in getting the b by itself? Good, multiply both sides by 2 so they cancel on the right, multiply the left by 2. What do we end up with on the left? 30x squared equals 5x times b, right? Because we're looking for b. Okay, then what do we do to solve for b? Divide by 5x. Okay, what happens with 30 divided by 5? It's 6, and then x squared divided by x is just x. So the base is equal to 6x, and what are our units? Just centimeters, right? Not squared because we're not finding the area. Not too bad, right? Okay, just got to be careful with the algebra there and making sure you're understanding what am I solving for? The b, not the x. All right, we'll go ahead and do this one. There's no variables in this one, but sometimes working backwards can cause some confusion. So what are they asking us to find here? Base 2, and what do they give us? Base 1, height, and the area. So what formula should we start with? Okay, and remember this formula is the one that I see often missed. You add the bases of a trapezoid. You multiply the diagonals of a kite or a rhombus. All right, so plug in what you know. The area is 231. That's equal to 1/2 of. Base 1 we know is what? 23. Base 2 is what we're trying to solve for, and the height they give us is 11. Okay, so what do you want to do to try to solve? Okay? Personally, I would probably do what Tyler said. I don't want to distribute the 1/2 because then I'm going to get fractions or decimals. I would probably choose to just multiply both sides by 2 to get rid of the 1/2. But you could distribute the 1/2 if that's what you would prefer. So I'm going to take this whole thing and multiply it by 2, so the 2 and the 1/2 will cancel. What's 2 times 231? 462. That's going to equal 23 plus base 2 in parentheses times 11. Now what do you want to do? Okay. You could distribute the 11 or? So remember that all of this is being multiplied from left to right. So it's not, if you multiply everything by 1/2 and then multiply everything by 2, they just undo each other. Does that make sense? Okay. So I could distribute the 11 or I could do what? Divide by 11. And again, it's up to you. Do you want to distribute the 11 or do you want to divide by 11? Okay, divide by 11. And again, all of that is being multiplied by 11 and all of it's being divided by 11, so they just cancel each other out. What is 462 divided by 11? 42. So 42, exactly. 42 equals 23 plus b sub 2, so we'll subtract 23, and b sub 2 is, good, 19 in just millimeters, not squared, because we're not finding area. So again, it could have been a little bit harder if we would have distributed the 1/2 and distributed the 11, just because the numbers might not have been as pretty, but that would have worked as well if you prefer. You've got a calculator for this test. With this test, the entire test, I'm pretty sure is I will make calculator. Maybe the bonus, not calculator, but most of the test will be calculator. So, okay. Any questions on that one? All right. So now we're down to the last part of the notes, and there should just be a few more examples, right? So we've got the kite and we've got the rhombus, and I'm again going to emphasize, because I see it so often in these formulas. First of all, for the rhombus, you're going to have to choose which one do I have enough information for. Do I know the base and the height of my rhombus, or do I have to use the 1/2 diagonal 1 times diagonal 2? A kite is not a parallelogram. It only has one formula. It is just 1/2 diagonal 1 times diagonal 2. But you multiply the diagonals, you do not add them. So be really careful. Okay, so this one's not too bad. We start with our formula. It's a kite. They give us area. They give us diagonal 1, and they want us to find diagonal 2. So what formula do I start with? So area equals 1/2 d1 times d2. All right, plug in what you know. A is how much? 238 equals 1/2 of d1 is how much? 14, and we're looking for d2. Okay, so again, it's up to you what you want to do here. What would you rather do first? Okay, I could multiply by 2. If I multiply by 2, it's going to make my numbers a little bigger. Totally fine. Or this time, it might be easier to do what? Well, because we could just go ahead and do 1/2 of 14, right? Because 1/2 of 14 is just 7. So remember that you're multiplying from left to right. There's no plus or minus. You're not distributing the 1/2. It's just 1/2 of 14 is 7, and that's multiplied by d2. The only time you distribute is when you have a plus or a minus sign. And then we would just divide by 7. And d sub 2 is equal to, you said 34 inches, not squared, because we're just finding the length of the diagonal, not area. Okay, let's try some more on the back. So what do you notice in this picture? Okay, they give you the whole diagonal 1 and the whole diagonal 2. So again, I want to point out that, do you notice how they did d1 equals, and they've drawn an arrow? So they're telling you the whole length of the diagonal. It's a rhombus. We have 2 choices. Which formula is going to be more helpful here? The second one, because they don't give us anything about the base or the height. So we'll start with A equals 1/2 d1 times d2. Plug in your diagonal 1. What do we get? What's diagonal 1? 8x plus 7. And what's diagonal 2? 14x minus 6. Now, be careful. Remember that you multiply from left to right and that the order of multiplication does not matter. What you do not do is you do not distribute the 1/2 to the first parentheses and distribute it to the second. Okay?
Sorry for interrupting. I'd like to take just a minute before we release all of our students, go down to the special study assembly. We'll make sure that all of our students realize that this is a solemn occasion. These are true heroes. These are men and women who have literally put their lives on the line for the freedoms that you have today, to be able to sit in a country free from tyranny, from terrorism. These are true heroes. I just want all of our students to know that at the conclusion of the ceremony, that you are free to step down, shake the heroes' hands, tell them how much you appreciate their service, to show them the respect and the honor that they deserve. We appreciate all of you. We have awesome students here at Silent Springs, and I appreciate all of you. We're going to release here about 7:50. We're coming to the pack, so be ready for the program when it starts at 11. Thank you.
He meant 10:50. Okay, so let's see if we can talk about this real quick before we go. So, you guys with me though? We do not distribute the 1/2 to both sets of parentheses. And what I usually find helpful is maybe to multiply out of order so you don't make that mistake. Bring down your 1/2 and go ahead and FOIL your 2 sets of parentheses first. So this is half of. If you didn't learn FOIL, then just distribute. Distribute's what it means. So it's fine. If you have a binomial times a binomial, some teachers teach it as FOIL, but it's just distributing. So what I usually do is bring my 1/2 down and just go ahead and distribute this. So what's 8x times 14x? Okay, be real careful. 8 times 14 you said is 112, but x times x is x squared. Okay, then distribute your 8x times negative 6. Negative 48x. Then go and distribute your 7 times 14x. So plus 98x, and then distribute the 7 times negative 6. And we get minus 42. Is everybody following that okay? Go ahead and combine your like terms. What's negative 48 plus 98? So we have 112x squared plus 50x minus 42. Is that okay? And then we distribute the 1/2. And now we're going to distribute it to all 3 terms here. So what is half of 112x squared? 56x squared plus what's half of 50x? 25x, and then half of negative 42? 21. So we have area equals 56x squared plus 25x minus 21 units, centimeters squared. So make sure that you do put square units on that one because it is area. Okay? There's only 2 more examples. I'll let you guys go ahead and just work on those until it's time to go, and then we'll check them when we come back. This is going to be due on Wednesday, like normal, right? Be due on Wednesday. You just won't have, don't worry about it tonight. You need to do it Tuesday night after the test. Okay? Yes. All right. So I'm going to go ahead and let's set this up real quick. So area of a kite, what's our formula? Careful. Okay, so right before we left, you guys were saying we need to figure out the whole length of the diagonal 1 and the whole length of the diagonal 2. There's some properties of kites that you have to use here. The first one we already reviewed today, and that is that the diagonals of a kite are what? Perpendicular. So all 4 of those triangles are right triangles. The other property we haven't mentioned yet. Remember that in a kite, you had two sets of congruent triangles, right? Morgan, will you leave it open because there's still people not here? Two sets of congruent triangles, right? Okay, so which two triangles in the picture would be congruent? Two on the top and the two on the bottom, right? So that means that if this length is y, what is this length? Y. So that is not the case going the other direction on the other diagonal. Everybody okay with that? Okay, so we need to figure out what is x and what is y. Once we find y, we can double it to get the other diagonal. Once we find x, we can add 28 to it to get the first diagonal. So how will we find y? Pythagorean theorem. So the first thing we would have to do is 28 squared plus y squared equals 35 squared. Okay, I'm not going to work it all the way out, but that is how you would find y. And then diagonal 1 would be 2 times y, right? Okay, then how would we find x? Okay, how would we find x, though? We have to find x. So how do we find it? We found y. Once we find y, we're going to know what y is. Okay, so then we would do Pythagorean theorem again. So the second thing we would need to do, what would our Pythagorean theorem look like for x? So y squared plus, exactly. So since we don't have time to solve this all the way out, everybody following that we would find y and then plug it in here? And then we would have y squared plus x squared equals 29 squared, and we could go through and solve for x. And then once we know what x is, diagonal 2 would be 28 plus x, right? Make sure you add them, not multiply them. And then we would just take those values and plug them in for D1 and D2 and solve. So this is a longer process, but just individual small problems to do to get there. Questions? Okay, if you look at the last example, so that's as far as I'm going to go there. It'll be in the filled in notes though, so if you want to look back at the filled in notes, it's all worked out for you. You can check that out. Okay, so let's look at this one before we run out of time. So the tile design shown is a rectangle with a base of 4 inches. So the base is 4 inches, and what's the height?
2.
You can go ahead and check it. Javi, you're the last one. The height is what? 2 inches. So if we have a base of 4 and a height of 2, and it says use the grid to find the perimeter and area of the leftmost shaded parallelogram. Okay, so first of all, what color is the leftmost shaded parallelogram? Orange. Okay, if we're looking at the left parallelogram, that would be this shape right here. Do you guys see that leftmost parallelogram? Okay, the yellow ones would both be triangles, and then we have that leftmost parallelogram would be orange. So we're trying to find the perimeter of it and the area of it. So let's start with perimeter. What's the formula for perimeter? 2L plus 2W. And then what's the area formula for a parallelogram? Base times height. Now remember, whatever you call your base, your height has to be perpendicular to it, okay? So let's talk about this for a second. If this is 2 inches, what is just this little piece here? 1. And if this is 4 inches, what is each of these little pieces here? 1. So that would make this 1, right? Okay. So we want to figure out the perimeter of that parallelogram. And we know that each of these triangles is 1 by 1. So that means this little triangle here is 1 as well, right? Okay, we could do Pythagorean theorem because this is a right triangle here. Or, if it's isosceles, what's the relationship between these angles? Congruent, so they are 45, 45, 90. And so that means that the relationship is, what's always across from the 45? S. What's across from the 45? So what's across from the 90? S squared to 2. So you could do Pythagorean theorem, or you could realize S is just 1, and so that makes this hypotenuse 1 square root of 2, or just square root of 2, right? So we have 1 plus 1 plus square root of 2 plus square root of 2. Or the perimeter would equal 2 times one of the sides, I don't know, sorry, this is not correct. Somebody should have stopped me. This is not the formula for the perimeter of a parallelogram. In the sense that you don't call the length and the width. That's the formula for the perimeter of a rectangle. So sorry. So fix that. The perimeter is just simply adding all the sides together, right? Okay. You do have two opposite sides and two opposite sides, but we don't really call them the length and the width because it's slanted. Okay? So this would just be, real quick, 2 plus 2 square roots of 2. Are you guys with me there? All right. And then area, we would just have our base and our height, 1 times 1, which would just be 1 unit squared. Okay? All right. And if you need help with that, again,